We are on page 3, and we are starting a new unit. The expressions, equations, and functions in this unit are going to be called rational expressions, equations, and functions. What's a rational number? Say that again? Has to terminate if you write it in decimal, but where does rational really come from? What? Ratio, which means? Fraction. Ratio, which means fraction. This whole unit is about fractions. However, these are not normal fractions. These are fractions with x's all over the place. So we are going to be looking at rational expressions, equations, and functions. A rational expression is a fraction where the numerator and denominator are polynomials. A fraction where the numerator and denominator are polynomials. Rational expression is just a fraction where the numerator and denominator aren't just numbers, but are entire polynomials. For example, maybe something like x plus 2 over x squared minus 2x plus 3. Or to give you a couple more, maybe x cubed minus 4x plus 1 over x squared minus 1. Or, this one has a really simple polynomial, constant polynomial for its numerator, just 1 over x minus 1. These are all examples of what we call rational expressions. And these are really what we're going to spend this entire week looking at. How to simplify these things, then how to multiply, divide, add, subtract. Rational expressions. As opposed to rational equations, what can you do with an equation? Solve it. I'm just going to say, for our kind of definition, but not really, can be solved. We get number answers. For example, maybe something like x plus 2 over x squared minus 2x plus 3 equals 1 over x minus 1. And our goal is to somehow figure out an x value that would make both sides of that fraction the same. That'll be next week. Actually, won't really be a huge deal when we get there next week. What can you do with a function? Graph it. These are things that can be graphed. We'll be there by the end of next week. So maybe something like f of x equals x plus 2 over x squared minus 2x plus 3. Or maybe y equals 1 over x minus 1. And this is basically the story of this unit. How to simplify these things. Bless you, that's today, tomorrow, and the next day. Equations, how to solve equations and get some number answers when one fraction with x's equals another fraction with x's. And then graphing, how can we graph these things with the x's? And some kind of strange things happen with that, but that'll be next week. It won't really be a big deal when we get there, but we'll see what happens. Now, as far as the simplifying goes, a lot of what we're going to do is going to be very similar to how you simplify regular fractions. So before we do like a multiplying problem, we'll look at multiplying fractions. Before we do a division problem, we'll look at dividing regular fractions to then use similar ideas when we have these rational expressions with x's in there. For example, you all know what 6/8 simplifies to. 3/4. But why? What was that? Yeah. What I'm going to do, not that this is really how you write it when you simplify, but I'm going to rewrite the 6 as a 2 times 3, and I'm going to rewrite the 8 as a 2 times 4. Again, this is really just to kind of set up what we're about to do with our x's in a moment. Lauren just said they have a common factor of 2. Well, what are you allowed to do if there's a 2 getting multiplied up top and a 2 getting multiplied on the bottom? Which means we can cancel them. I can cancel out the 2 from the top and the 2 from the bottom to get 3/4. I was able to do this because I was able to rewrite the top as a multiplication problem and the bottom as a multiplication problem. And then I just canceled any common factors that they had. So we are going to use very similar ideas with these rational expressions. First one, that's in that box on the bottom. What we need to do is we need to factor the numerator and denominator. Step number 1, factor the numerator and denominator. And absolutely everything we know about factoring is going to come back here, factoring out the GCF, difference of two squares, box method, X method, all that good stuff is going to show up with this factoring. If I said to you, factor 20 plus 40x, hands, if you can tell me how you would deal with this. Alyssa. Take out a 20. Whenever you factor, you should start by looking for a GCF, and there is one here. There's a 20, so I'm going to go and I'm going to take that out. And I'm going to write 20 times 1 plus 2x. And the bottom is just 20 times x. It's already fine as is. My goal was to rewrite the numerator and denominator as multiplication problems, which I've done. 20 times 1 plus 2x, and just 20 times x. We already just had that as 20x. Any ideas what I might be now allowed to do, Lionel? Yeah, just like in the previous example where I canceled out those 2's, now I'm just going to cancel any common factors, and in this case that happens to be the 20's. So step number 2, cancel any common factors.
Could you put a 20 on the other side and put the 1 plus 2x over x and
Say that one more time.
So put the 20 on the outside and then put the 1 plus 2x over x all in a bunch.
No, because, okay. If I did that, if I said 20 times 1 plus 2x over x, well, when you multiply something times a fraction, well, we need to multiply the numerators. The denominator's 20 is the same as the fraction 20 over 1. So it would show up at top, but not in the bottom. So no, we can't do that. We're going to cancel the 20's. Gone. Gone. We are going to get 1 plus 2x over x. That is our simplified fraction. Now, there's something very tempting to want to be able to do that you are not allowed to do. It would be really nice if I could just kind of cross out those x's. No, you're not allowed to do that. Here's why. Let's say you have 1 plus 3 over 3. That's 4/3, right? Can I just like cross out the x's? Well, not the x's, the 3's. No, for the same reason I can't do that, I can't cross out the x's over here. My answer, 1 plus 2x over x. Anything with that? We're factoring and we're canceling. Turn the page. Page 4. And let's make sure everything but the math is away. We shouldn't have like other things. Okay, just checking. Letter A. I would like to see if you can factor something out of the top and you can factor something out of the bottom. I think you can. Shay, what can I do in the numerator?
4 times x plus 5.
Good. Start by looking for a GCF. There is one. 4 times x plus 5. Dawson, what about the denominator? Good. Is there anything I can do? What can I do? Is there anything in common? Learn? the x plus 5s. I can cancel this. I can cancel that. This is actually just going to be the regular fraction 4/3. And I think this one's kind of interesting. What this actually says is if you plug in any x value, plug in any number for x to the top and the bottom, any fraction you get would be simplifiable to 4/3. Letter B. I see a GCF in part. I don't in the other part. But I think you know how to factor. See what you can do in part B. GCF up top, something different on the bottom. Honestly, what we're doing now is why I keep putting all that factoring on the cumulative reviews, because we've got to be able to use all of our different factoring techniques with these problems. Braden, what's happening up top?
X minus 5.
Yeah, it's just a GCF thing, so x times x minus 5. Brittany, do you have the denominator?
5 minus x squared minus 5.
Yeah. There isn't a 5 that I could take out, Paige.
X minus 5, x plus 5.
This is my difference of two squares pattern. I couldn't take a 5 out of the x squared, but I can factor this into x plus 5, x minus 5, because x squared is a square, 25 is a square. I've got that. Now's the fun part. What cancels? Gone. Gone. Your answer is x over x plus 5. Can I now just go cross out those x's?
No.
It's not part of a factor. No, you're not allowed to do that for the same reason that I showed you. You can't cross out the 3's over here. X over x plus 5 is the answer. You know how to do letter C, I think. Go do letter C. Don't yet go on to D. Well, I think we could do it, but just letter C for right now. If you do it correctly, there should be a common factor that you'll then be able to cancel. It's usually going to happen with these things. Tyler, how did you factor the top?
X plus 8 and x plus 5.
That sounds good. Brett, how about the denominator?
X minus 7 and x plus 5.
Good. Josh, can I do anything?
Cancel the x plus 5.
X plus 8 over x minus 7. What this also means is if you pick any x value and plug it into this thing, you'll get the same fraction as if you just pick any x value and plug into this version. It's just a simplified version. Letter D, GCF.
No.
How about the denominator? GCF?
No.
So? What? Well, yeah, sure, everything is factoring. But like, draw a box, make an X, do whatever you do to factor those things. That's also why I've been putting those on cumulative reviews. Take a few moments, do some factoring. I realize something like D may take a little longer. See what you can do. hopefully your setups are looking like those. Either one, I don't care how you do it. Okay. Does this kind of look like you're factoring, maybe? 2x plus 1x minus 4 on the top, and 2x minus 1x minus 3 on the bottom? No, what'd I do? This is definitely wrong. Oh, and I see exactly what I did. That's not that. That's this. That's this. That's that. You like that any better? Okay. 2x minus 1, x plus 4, over 2x minus 1, x minus 3, gone, gone, x plus 4, over x minus 3. You use the box. I think your box should end up looking like those. X plus 4, 2x minus 1, x minus 3, 2x minus 1. Yes, can we factor? I'm not getting much response.
Yes.
Okay. Next, we need to multiply fractions. How do we multiply fractions? 1/6 times 2/7. Multiply regular fractions, only one person remembers? Really? Brett?
Do we just go across?
Yeah, so what would you get?
2 over 42.
Yeah. And then? And then we'd simplify 1 over 21. To multiply, we just multiply straight across. Not a big deal. And then we simplify. So now we need to use this idea with our rational expressions. Turn the page. We need to multiply this fraction times this fraction, and that's a mess. Here's what we're not going to do. We're not going to start foiling, because it's going to be very, very difficult to try to simplify once we've done our foiling. Before we do any multiplying, we are going to go and we're going to factor all the numerators and all the denominators. Step number 1, factor all numerators and denominators. Looks to me like that first numerator is a box or an x problem. First denominator is already as factored as it's going to get. And then I feel like you can figure out the second one. I want you to take a few moments right now, factor all those pieces. So you're going to get one fraction over here times another fraction with just all the pieces factored. Hopefully only the first numerator is kind of tricky. I think the others should be reasonable-ish. Bless you. Mina, have you found your first numerator?
Yeah, just one.
Good. 2x plus 1 times x plus 3. Kiara, how about that second numerator?
X plus 4, X minus 1.
Yep, just our difference of two squares pattern over there. Sam, how about that denominator? X plus 3, x plus 5. Perfect. Any factoring issues?
I got 2x plus 3 and 1.
Okay, so what do you do, the x or the box?
Box.
Okay, so if we're doing that, 2x squared plus 7x plus 3. X and x. 1 and 2, plus and plus. I've got 1, 3, 3, 1. If you put the 1 here and the 3 here, that's going to give you 3x plus 2x. That's going to give you 5x, and I want 7x. So maybe?
Yeah, I just realized this is.
So I think that should work. Step number 2, we're going to multiply. This is not as horrible as you think. By multiply, I just mean, well, you told me before, how do you multiply fractions? Multiply across, multiply the numerators, multiply the denominators. I am going to stick all the factors together in one big fraction. That is going to be what I mean by multiply. Stick all factors together in one fraction. So when you multiply those numerators, you're going to get 2x plus 1, and x plus 3, and x plus 4, and x minus 4. When you multiply the denominators, you're going to get x minus 4 times x plus 3 times x plus 5.
Simplify. Okay.
So I kind of want to multiply first, and then I'm going to go and simplify that big thing that I have. So yes, we're absolutely going to simplify. I'm just not doing it just yet. But absolutely.
Can't do the where it's like x and 4, like x minus 4 and x minus 4.
Like cross
that.
cancel?
Yeah.
But I guess the question is, why are you allowed to cross cancel? And the reason is because when you multiply, you just stick them all together. And now they're one big fraction. Of course now. That's what I'm going to go do. I don't really care, but
Oh, okay.
for other things, I think it will be easier if we first just stick everything together.
Okay, so we're still cross canceling.
Yes.
Okay.
Yes.
Alright.
What's going to go? Just say it.
X plus 3.
X plus 3, gone. X minus 4, gone. My answer is 2x plus 1. X plus 4 over x plus 5. So step number 3 is just going to be cancel any common factors. And that is it with that. Factor. Factor, factor, factor. A lot of factoring. Stick the numerators together, stick the denominators together. Then you cross things out. That was a much more difficult example than what's on the bottom of the page. Go do the bottom of the page. Silas, do you have that first numerator? Yep, that's our difference of squares pattern. And I can't do anything in the first denominator, so I'll just stick parentheses around it and move on. Same deal in the second numerator. Can't do anything there. Molly, what about that second denominator?
It's a times a plus 2.
Yep, there's just a GCF that we can factor out. I'm going to go and multiply, and anytime I have just a letter by itself or a number by itself, I usually just move those out to the front. I feel like they kind of get lost if they're in the middle, and it's easy to forget about those. So I'm going to get a plus 2, a minus 2, a plus 1 over a plus 1, a plus 2. So, Natalia? Perfect. A plus 1, a plus 2, those are gone. A minus 2 over a. And I guess what I really need you to realize is multiplying is really just like simplifying. There's just more factors. That's it. Anything so far? Can we do this so far?
Can I see the top one?
Uh-huh. Turn the page. Now we divide. Dividing fractions. So much fun. How do you divide fractions? What was that, Braden? What do you mean by that?
Use the reciprocal of the both the other side and the first side and then you multiply.
Perfect. We never actually divide fractions. Instead of dividing, we're going to multiply by the reciprocal of the second fraction. So 1/4 times, this is 7/3. You're going to get 7 over 12. And I don't think I can do anything here, but if I could, I'd then simplify this. Same deal is going to work with our rational expressions with the x's all over the place. To divide rational expressions, we are just going to multiply by the reciprocal of the second fraction. We are never really going to divide these things. Instead, I'll multiply by the reciprocal.
Yeah, you can tell me if I'm joking or not.
Okay.
But, so, are we going to simplify the problem? Like, simplify the second fraction first, but after?
Probably after, but my first step is not going to, I don't know. I don't really know what before and after means for you, so hold on 1 second to that. I don't want to do this problem. Instead, I want to do the related multiplication problem. So I'm going to start by just writing it as a multiplication problem. I'm going to say a squared plus 2a minus 15 over a squared minus 16 times 3a minus 12 over a plus 1. I'm just going to write it like a normal-looking multiplication problem. Now I think you know how to multiply.
Well, yeah, my question was like, do you simplify before you do the reciprocal?
It really won't matter.
Okay.
I usually just first flip the second one only because I feel like when people just start factoring, sometimes they then forget to flip it and then things aren't going to cancel. So I usually just flip it and now go. This is now exactly like the last page. Go do your factoring and canceling. Do not go on to B. Weird things happen in B that I need to talk to you guys about. Alyssa, do you have that first numerator?
3 plus 5 and
Good. Silas, what about that first denominator? Good. A plus 4, a minus 4. Manya, do you have the second numerator? Yep, just a GCF thing, 3 times a minus 4. And there's nothing I can do here other than I'll just stick some parentheses around that. I'm going to multiply. And so I don't lose it, I'll put the 3 out front. So 3 times a plus 3, a minus 3, a minus 4, over a plus 4, a minus 4, a plus 1. Now the fun part, the easy part. What goes? Gone? Gone? I guess that's it. That's okay. We could have several factors left. We're going to get 3 times a plus 5 times a minus 3 over a plus 4 times a plus 1. That's our answer. Questions or problems? Letter B. We're not going to divide those. We're going to multiply. Go rewrite letter B as multiplication, but don't start doing any more work. Just rewrite it, because there's some weird things we have to deal with. No? Not weird? No, it's not that weird. We just haven't yet done a problem like this today. I hope you have that. No? Well, so you're already a step ahead of us. What do I think is a little strange about this? Actually, I've got a couple things a little strange about this. We need these things to be in standard form so we can factor. So let me go and rewrite them. I'm going to rewrite this as negative x squared minus x plus 2 over x plus 3 times x squared minus 9 over... Was the denominator okay, or does that have to get moved too? We should. So how, Lionel? Yeah, negative x plus 1. Put everything in standard form. Now I have a new problem. What looks weird? Yeah? We can't have that. Our leading term has to be positive. How can I deal with it? And let me tell you what you're not allowed to do. We can't, multiply by negative 1 because it's not an equation. But I could do something related to that. Yep. That's when we have negative powers. That's not going to work over here. Lauren? That's how we're going to deal with this. Our trick is going to be factor out a negative 1. So I think I want to actually add that in here in words. We're going to say factor out the negative 1. And I think I need to do that in 2 different places, in my first numerator and my second denominator. So this is going to be negative 1 times x squared plus x minus 2 over x plus 3 times x squared minus 9 over negative 1, factor out the negative 1 there, times x minus 1. I have nothing else really new to explain here. Finish it off. Do some factoring, do some canceling. The negative 1, that's just like a regular number that you can kind of move out front and do some simplifying with. So see if you can finish this one off. Brittany, what's gonna, do you have what I have, by the way? What's gonna go? Good. Anything else? -1, just like a normal fraction, -1 on the top, -1 on the bottom, those are going to cancel. And we are going to get, oh, this is kind of weird. What's the denominator? 1. Do you actually need to say that? We could say this, but it's probably best just to say x plus 2x minus 3. I think it probably should just be factored like this, so I would leave it like that. No need to FOIL. If you do, you're not wrong. But if you FOIL and you FOIL wrong, then I have to take off points. If you just leave it factored, well, you're fine. Anything here? One last piece for today. And looking at the time, there's no way I can stretch out these last 3 examples to like 20 minutes or so. So we'll do these, and then maybe I'll just give you time to start working on the homework for this stuff. By the way, so hopefully by now we can simplify, multiply, divide. Why would you think I would teach you how to multiply and divide before adding and subtracting? Why?
You have to have a base common factor and multiplication ratio. Times that.
Yeah, remember when you add, subtract normal fractions, you need a common denominator? We're going to save that for tomorrow because that's more involved. Multiplying, just multiply straight across, not a big deal. We actually did save the tougher stuff for tomorrow. We'll deal with that later, though. We need to look at these horrible, scary-looking things that are not going to be so terrible called complex fractions. Complex fractions are just fractions with fractions inside them. My numerator is an entire fraction, 1/2. My denominator is an entire fraction, 3/4, and I want to simplify a 1/2 over 3/4. What did you just?
You have to multiply by the reciprocal.
Okay, before doing that. Yes, absolutely, you're right. But before that, isn't a fraction, though, just a division problem? Mm-hmm. This problem is really just saying, I want you to do 1/2 divided by 3/4. Now, Lauren, what's the deal?
Well, you have to do the reciprocal.
We never really do division, though. We're going to multiply by the reciprocal. 1/2 times 4/3. It's not bad. 4 over 6. And your answer is 2/3. Basically, all you need to know is these are going to look terrible. Write it as a normal-looking division problem. Write that as a normal-looking multiplication problem. And go. The simplifying is a little bit different, though, in the next one. So I'm first going to just write this thing out as m cubed over 3n divided by negative. I'll stick the negative with the numerator. Doesn't really matter as long as it goes in one of the places, but not both. I've got that. Tyler, now what?
Do the reciprocal.
Yeah, not really doing this problem. I'm really going to multiply by the reciprocal. So m cubed over 3n times, and of course, just be careful with your m's versus n's. There isn't really any factoring stuff here. That's okay. This is really just kind of like a laws of exponents problem. I'm going to say 9m cubed n squared over negative 3 m to the 4th n. I think you know how to simplify that. Finish it. You can. I think it would just be easier to just get one big fraction, don't even bother and then just simplify that.
Okay.
Only because, yeah, you can, but after you multiply that, there may be more things to simplify anyhow. I would rather just simplify once than simplify and then do it again. But you're not wrong. Molly, what do you have?
Negative 3m over.
That's it. The last one is about as tough as these can get, but I feel like we've already talked through all the different pieces of that. So I want you to take a few moments right now. Try that one. Definitely feel free to check in with people near you, but see what you can do. And I think if we can do this, we're in good shape for today. Bless you.